Here's what you've been waiting for. On page 11 of the projectile package, we're going to do question 21. On planet physics alpha, where the acceleration due to gravity is 16 meters per second squared, a projectile is launched at 34 meters per second, 30 degrees above the horizontal from the top of a 376 meter high cliff. Determine the time of flight and how far from the base of the cliff does the projectile land. Okay, so we have a cliff that's 376 meters in height. And from the top of the cliff, we're launching a projectile. And the speed that we're launching it at is 34 meters per second. And the direction that we're launching it at is 30 degrees above the horizontal. So we start from the horizontal and go up 30 degrees. So that is the speed that we're launching it at. So we need to break it into its components. So we pull up the calculator. And we do 34 cosine 30 to get the adjacent. So the adjacent of this will be 29.44 meters per second. And 34 sine 30 will be 17. Okay, so those are the components of it. We now fill in the table. So gravity is down. So this acceleration downwards vertically is 16. The initial speed is 17 up. And the displacement is all the way down, 376 down. Horizontally, it's going at 29.44. Okay, so the initial speed is 29.44, but so is the final because there's zero acceleration horizontally. So I'm going to be writing it as a big 29.44 in both of those, just to emphasize that the velocity doesn't change horizontally. Okay, so we now need to calculate the velocity and the time. Okay, and the velocity, we'll do it from Vf squared equals Vi squared plus 2AD, because that's the formula without the velocity. And that's going to be 17 squared plus 2 times the acceleration times the distance. And that's going to be Vf squared. Now let's just worry about the directions right now. This is down and that is down. So when we multiply that together, this will be positive because they'll both be the same sign, whether they're both negative or both positive. When we multiply two negatives together, we get positive, or two positives together, we get positive. The 17 squared will always be positive as well, so we're eventually adding that all up. So 17 squared is 289, and then we have to add 2 times 16 times 376. That's a big number. Add 289, and then square root it. Oh, I love that. Palindromic. Square root that number, 111. So filling in the things, it'll be Vf squared. Vf squared is going to equal the 289, I believe it was, and 12,000, sorry, and 32. So Vf squared was 12321. So Vf is going to equal 111, and that will be in meters per second, and that will be down. Even though it's plus or minus, we know it's going to be, we're going to choose the downward one. 111 down. Now, the time of the flight is going to do the change in the vertical velocity over the acceleration. We're going to use that from the definition of the acceleration, is the rate of change in velocity over time, that formula. and we get 128 is the difference from 17 up to 111 down over 16, and that is exactly 8 seconds. So this is 8 seconds. And now horizontally, the distance, the range of it, is equal to velocity horizontal times the time. And the velocity horizontal is 29.44 times 8. So I will take that number I calculated already up here, 29.44, take that number and multiply it by 8. So the range is 235.6 meters. That's how far the horizontal range is. The time is 8 seconds. Those are the two answers that we're looking for. Determine the time of flight and how far from the base of the cliff. Thank you. Remember, smash that like button and subscribe.